Hello, Pranesh. Can't hear you. Hello, Kritika.
Hello, sir.
Can you hear me? Sapale, what you do is you unmute yourself and turn on your videos, Panila, so that we can see each other. Can you see me?
Yes, sir.
And where is Pranesh? Can he see me? Can you see me?
Yes, sir.
Yeah, you both of you, why don't you turn on your videos also so that I can see you, right? Okay, Kritika. Hello, how are you? I can see you now. Where is
Fine,
Pranesh?
sir.
Okay, that's okay. That's okay. And are we only two here or we have somebody else coming in? Okay, Kritika, you tell me something about yourself. Which school did you go to?
SOS.
SOS.
Yes, sir.
So you want to continue there or you want to go to some other school?
I don't want to continue there.
Why? That's a very good school, right?
But still, I want to try St. Javier.
That's okay. That's okay. I just want to know, like, people are trying to your school and you want to shift your school. Anyway, Pranesh, how are you?
I'm fine, sir.
Which school do you go to?
Noble Academy.
Noble Academy, Banesar.
Yes, sir.
And you also want to switch your school?
Yes, sir.
Okay. So which one do you want to go to?
Probably St. Javier.
Good luck with that. You'll have a lot of competitions for that. So you'll have to try working hard, okay? So you both want to go into science, right?
Yes, sir.
Why do you want to go and study science? Pranesh, why?
It creates further more options.
That's good. That's good. Okay, it creates more option. That's okay. And Kritika, why do you want to go into science?
Because I love this subject.
That's the thing I want to hear, right? We love the subject. That's why we want to go into it. Okay, let's start into chemistry, right? I will be teaching chemistry. Okay. And believe me or not, chemistry is one of the most boring subject. Okay. It's very abstract. Normally what happens in Nepal, we don't do too much of lab activities. Therefore, you find it very boring, but I'll try to make it interesting. And then today we'll learn very basic and very, very simple concepts. And I would like to start from, the concepts that we had done yesterday, okay? So I want everybody to turn on the videos so that I can see you and then you guys are obviously seeing me. So it'll be more like in a class if I can see you. Pranesh, Prayus, and Ritu, all of you, can you turn on your videos? Hello. Okay, now are we ready to start?
Yes, sir.
Okay. I'll start from what was left over yesterday. I think Rijendra sir taught you about atoms, right?
He taught us about Charles, like a little bit concept of.
Okay. So we'll be today dealing with atoms, and then we'll try to see what are the things that makes up an atom, and then we'll try to play up with these fundamental particles that are present in an atom and see what we can make up, okay? So I'm going to share my screen. If you don't see that, then you tell me, okay? Can you see anything in the screen? Hello?
Yes, sir.
What can you see?
Atomic structure of helium.
Okay, atomic structure of helium. That's good. So now, what do you see now? Can you tell me anything?
Periodic table,
Uh-huh.
proton, neutrons, and electrons.
Yes. Okay, now,
Orbits.
very good. Let's see here. What we have in the center is a circle, right? Those are called orbits. In the middle, you have a cross. That's the nucleus. We have the fundamental particles here. That's a proton, that is neutron, and this is electron. And here are two types of models. First thing what you have to understand is now when you are going to start your grade 11, there are many things that will come across that you had studied before and now you find it not true. Okay, so here also what you have studied before is an atom that has a centrally located nucleus and you have an orbit outside, but there is other concept of an atom that is also called a cloud concept, and we'll see what happens when we do with the cloud concept. But you'll have to be prepared to know that these things that you have studied in grade 10 may not be true, or you have more in advance to learn from that. Here, when you go to the top right, you see the periodic table. Just below that is a net charge. You have a mass number here. We don't have anything here. Therefore, we don't see anything in these all factors, okay? So now let me go and put an electron in an orbit. Tell me, what do you see in the charge? Who is going to tell me? Unmute yourself and then you can tell me, okay? Pranesh, tell me, what do you see in the charge here just below the periodic table?
-1 negative.
-1 negative, very good. So when I take it out, now what do you see the charge?
None.
No charge, very good. Now let me go and put a neutron in the center. Now Ritu, can you unmute yourself and tell me, what do you see in the charge there? Hello, yes, Ritu, tell me, what do you see in the charge here?
Sir,
How
I'm
much?
not getting it.
You didn't understand me?
Yes, sir.
Okay, now look here, we don't have anything here, right? I want you to focus here. What is the charge here? It's 0. Now what I do is I put a neutron in the center of an atom. That's in the nucleus. What is the change here? What do you see here still?
0.
0. Okay, that's very good. Now, who will tell me, who else do we have? Pranesh, Kritika, and Ritu only, or we have Kritika, Ritu, and Pragyan? Paryan? Pranesh, Ritu, and who is the other one? Prayan?
Prayus.
Okay, Prayus. Okay, Prayus, hello, how are you? Now, you say, did you see what happened when you put a neutron here? Is there any change in the charge here?
No, sir.
Then what can you tell about the charge present in a neutron? What charge does it have?
No charge.
No charge. But nowadays, for your standard, that's okay to say no charge. But nowadays, what it is known is neutron is also charged, but they have equal number of charge like positive and negative. That's why neutron is called neutral, right? Okay, now let's go and put a proton here. Now tell me, what is the charge here?
+1.
+1. Very good. So what happens is electrons are negatively charged, protons are positively charged, but neutrons are neutral. Do you understand this in terms of charge?
Yes, sir.
Okay. Now look at this atom. You see, it said hydrogen atom. And here on the top, it's called neutral atom. Why is it called a neutral atom? Anybody can unmute yourself and talk. Why is it called a neutral atom?
It has equal number of protons and electrons.
Okay, equal number of protons and
Electrons.
electrons. Very good. Now, what I will do is I will add one more neutron and one more proton to it. Now look in here. What is the change? In the previous case, there was neutral atom, right? But now here you have an ion. So can anybody tell me ion is it charged or is it neutral? Anybody can unmute yourself and tell me, is ion charged or is it neutral? It is
charged.
It's charged. Very good. So here helium ion is what charged?
Positively charged.
Positively charged. Very good. Now who is the one talking very less? Maybe Ritu, you tell me, why is it positively charged? Why is it positively charged, Ritu?
Because there are number of protons.
There are number of protons, but there are electrons also. But why is it a positive charge?
Because there are more number of protons than electrons.
Very good. So we know that protons are positively charged, electrons are negatively charged. How many protons do we have here? 2 protons. And how many electrons here? It's only 1 electron. Therefore, you have a 2 positive charge and a single negative charge. So remaining charge is 1. Therefore, what do you have? You have a +1 charge. Now let's say this single one there is, right? Now let's put another one here. Now it becomes lithium. Okay, it's still positive. Why? You have more number of protons compared to electrons. Now, if you want to add more electrons like this, look at this. Now it's neutral. Why is it neutral? The number of proton equals the number of electrons. So in a neutral atom, then what should be there in a neutral atom then? In terms of fundamental particle, an atom is neutral when? Anybody can unmute and tell me.
When number of protons is equal to number of electrons.
Okay, so if you have number of protons and number of electrons equal, then what happens? The atom is neutral. In most of the cases that we see in the nature, what happens is the atoms are in the neutral state, okay? That's why we don't get an electrical shock whenever we touch something. But if you have a shock or electrical current flowing through it, then there should be a charge like you have learned in physics. But in real life, most of the things are neutral. Why? Because you have equal number of protons and the number of electrons. This is the one. Now I think let's make it clear. What did we do till now? What we did is we examined the charge present in an atom. What did we find out? We found that protons are positively charged, electrons are negatively charged, and neutrons are neutral. And protons and electrons play a fundamental role in developing the charge in an atom. If there are more number of protons compared to electrons, they are positively charged. If there are more number of electrons compared to protons, they are negatively charged. So can anybody tell me what are charged particles called? Anybody can tell me what are charged particles called?
Ions.
Very good. It's there, right? The charged particles are called ions. Now tell me, how many types of ions can we have?
2 types.
What are they?
Positive and negative.
Very good. Positive and negative. And I heard in the background somebody saying cations and anions. Yeah, right. Positive charge are called cations and negative charge are called anions. Very, very good. Do you understand this in terms of charge?
Yes, sir.
Okay, so in terms of charge, what we can have an atom, atoms can be charged as well as neutral. When are atoms neutral? Whenever there is the number of protons and electrons are equal, then the atoms are neutral. If the number of protons and electrons are not equal, the atoms are not neutral and they are called ions. If protons are more compared to electrons, they are positively charged and are called cations. If there are more electrons compared to protons, then they are called negatively charged ions or anions. Are we clear with that?
Yes, sir.
Okay, now just look at the column, the space here called mass number, okay? So we'll learn something about mass number again. So let me reshuffle everything and reset here. Now look at that, there is empty, now I put on electrons. And I have mass here. First, let me bring it back then. Look at only the mass number here, okay? Don't focus on anything else, look at the mass number here. What is the mass number now here?
0.
0, very good. Now let me go and put on the electrons. What is the change in the mass number?
No change.
No change. Okay, let me go and put 2 electrons. What is the change?
Nothing.
Nothing. Let me go and put 3 electrons there again. What is the change?
Change.
There's nothing changed. But let me go and put a neutron now. So what is the mass there?
1.
1, right? So what can you tell about the size of or the mass of electron compared to the mass of neutrons? Just think and tell me, how can you compare the mass of an electron compared to that of neutrons? What is it? Now let me, anybody wants to talk or anybody wants to say? You can try, because if you don't try and discuss, you'll not learn, okay? You can try, you can discuss. Here we are so few people that we have one-on-one interaction. Even, what do you want? Question, okay. Look here, I had 3 electrons in this particular orbit, 2 here and 1 in this second orbit. And when you look at the mass number, still it reads 0, right? Now what I do is I put a neutron here and all of a sudden the mass number reads 1. Now I want you to think about or compare the mass of neutrons with that of electrons. What can you say about the difference in mass between neutrons and electrons?
No idea.
No idea? Okay, imagine, I'll give you a situation, okay? So now imagine, let's say you are 50 kilos on average. Okay, anybody, let's say Pranesh is 50 kg. Okay, I don't know how much you are, or if you know, you can tell me, what's your weight?
Around 56.
Okay, let's say you are 56 kilo and then you are on a balance and that balance reads 56 kg, okay? Now what I do is I put a small piece of paper into a pocket, and what do you think will be the change in the mass? Very, very tiny piece of paper into your pocket while you are still in the balance. What would be the change in mass?
There's no change.
No change. Do you all agree with that? Everybody?
Yes, sir.
Yes. So then what can we say? The mass of paper compared to mass of Pranesh is what? Negligible, right? That's too little. That doesn't make a significant effect. But now I take a very, very sensitive balance, a scientific balance that can measure very, very, very small amount of weight, and I put a piece of paper. What do you think? Will the paper be weightless or will it have some kind of mass?
Some kind of mass.
The mass.
It'll have some kind of mass, right? But the mass of paper compared to the mass of Pranesh is negligible. Here also what happens is electrons have mass. These are not massless, okay? They have mass. But what happens is, compared to the mass of neutron, the mass of electron is negligible. Therefore, if I put more electrons here, you don't see the change in the mass number here. Do you understand what I say?
Yes, sir.
Yes. So then these neutrons are much, much, much more heavier compared to these electrons. If you compare this with me, I'm 75 kilos, then these electrons are piece of papers. So if I put these electrons into my pocket and then weigh again, I will not change, or it will not show a significant change in the mass of mine. Similarly, here also, we don't see the change in the mass of an atom when you add electrons. Why? Because the mass of electron is very, 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 very less compared to the mass of proton, no, neutrons. Now let's see what happens when you put proton. What do you see in the mass number here now?
2.
2. So what do you think? The mass of proton and mass of neutron, is it almost comparable? Is it almost similar? Or the mass of proton is very, very, very less compared to the mass of neutrons?
Similar.
Very similar. Therefore, what happens when you add, if you don't add a proton, it's just 1. If you add a proton, then what is the mass now? 2. Therefore, mass of proton and neutrons are almost comparable. Almost comparable. If the mass of hydrogen is 1 and the proton is 1, the mass of neutron should also be around 1. Now, अघि चाहिँ हामीले के कम्पेयर गर्यौं त भन्दाखेरि इलेक्ट्रोन र न्यूट्रोनको मास कम्पेयर गर्यौं अरे. Now you tell me, what would be the mass of electron compared to that of proton? What would be the mass? के हुन्छ होला मास प्रोटोन र इलेक्ट्रोनको मास?
फरक हुन्छ.
फरक हुन्छ कि सेम हुन्छ?
Different.
फरक हुन्छ. Okay, they have different, but is electron heavier than proton, or is proton much heavier than electron?
Proton heavier than
electron.
Proton is much, much, much heavier than electrons. Okay, so although look here now, what are the 3 fundamental particle present in this ion? यो आयनमा 3 वटा fundamental particleहरु छन्. के हुन् तिनीहरु?
Electron, protons, and neutrons.
Electrons, protons, and neutrons. But when you look at the mass number, what happens? The mass number depends only on the number of neutrons and number of protons. So if I add 1 more proton, look here, the mass number will change. If I add neutron, again the mass number will change. But if I add electrons, the mass number will not change here. What does that mean? Mass of an atom depends on only what?
Protons and neutrons.
Protons and electrons. Now if I ask you to protons and sorry, not electrons, protons and neutrons. Very good. Now if I ask you to define what is an atomic mass, what would you tell me?
The sum of number of protons.
Sum of number of protons and neutrons.
The sum of number of protons and neutrons is called an atomic mass. That's exactly what I want from you. That's, look here now, the questions that you have to answer, and you'll have to understand the question very well. I did not ask you, how will you find out the mass of an atom? Did I tell you that? मैले atom को mass कसरी पत्ता लगाउने हो भने चाहिँ प्रोटोन र न्यूट्रोन को सम निकालेर एटमिक मास पत्ता लगाउने हो भनेर आन्सर गर्न मिल्छ. तर मैले यहाँ सोधेको क्वेशन को उत्तर के हो त भन्दाखेरि what is atomic mass भनेको छ. Okay, so normally धेरै स्टुडेन्टहरुले बुझ्नु पर्ने चाहिँ के हो त भन्दाखेरि एटमिक मास भनेको चाहिँ कसरी पत्ता लाग्दो रहेछ त? न्यूट्रोन र प्रोटोनलाई एड गरे भने एटमिक मास पत्ता लाग्दो रहेछ भन्ने कुरा you need to understand, you are clear with the concept. तर हाम्रो डेफिनेसन चाहिँ there is a standard definition. So if you are asked define what is atomic mass भने चाहिँ, if you just write down the mass of or the number of proton plus the number of neutron, it's called atomic mass भने you may not be right, you may not be correct. So how do we define mass number? Mass number define garna. I will just say, I'm Mahendra. Okay, you all. I didn't introduce you myself, but my name is Mahendra Thapa, and then I am 75 kilos. So Mahendra Thapa is mote ki duble. Yeah. Come on, tell me. Mahendra Thapa is mote ki duble.
ठिक्क छ
Huh?
ठिक्क
Tikka?
छ
Anybody else? Tell me, am I mote or duble?
Mote, sir.
Mote, okay. So one said tikka ko, one said mote, and any other answers?
Depends upon height.
Depend upon height. Okay, I'll tell you my height. I am 5'7".
Mote.
Then mote, sir.
Mote, okay. Now look here. If I say I can become mote and double at the same time, do you agree?
No.
No? Anybody else? Come on, tell me your thoughts. I say
Yes.
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 Okay. मैले चाहिँ के भन्ने भने एकैचोटी महेन्द्र थापा मोटे पनि हुन सक्छ दुब्ले पनि हुन सक्छ भन्ने एकै पटकमा right now I can be mote as well as double. Do you agree?
Yes.
Yes.
How?
In comparison to other people.
Yes.
Very good. Very good. You guys are smart. So जे पनि वर्ल्डमा के हुन्छ त रियल वर्ल्डमा what we do is केही कुरालाई नाप्दाखेरि अथवा केही कुरालाई चाहिँ तिमीले इभ्यालुएट गर्दाखेरि there is always a reference standard. So if you compare Mahendra Thapa, who is a 5'7" height, with a sumo wrestler, maybe he's also a 5'7" height, but you see Mahendra Thapa is very double. Right? होइन र महेन्द्र थापालाई सुमो रेस्लरसँग चाहिँ कम्पेयर गर्ने हो भने त महेन्द्र थापा त दुब्लो भयो नि त. But at the same time, if you compare Mahendra Thapa with somebody who is very, very thin, 40 किलोको 5 साइड हाइट भएकोलाई 40 किलोको मान्छेसँग कम्पेयर गरेर Mahendra Thapa is very mote. Okay, so Mahendra Thapa at the same time becomes mote as well as double. Why? Because the reference standard you are comparing is different. बुझिन्छ यो? Do you understand what I'm saying?
Yes, sir.
Okay, now what happens is here also if you define mass number कसरी पत्ता लगाउने हो भनेर कसैले सोध्यो भने how do you find out the mass number of an atom भन्यो भने चाहिँ what you can say is we can find the mass number of an atom by summing or by the summation of the number of protons and neutrons भन्न मिल्छ. But if somebody asks you what is the mass number or what is the mass number भनेर सोध्यो भने चाहिँ हामीले जहिले पनि के गर्छौं भने कुनै पनि एउटा रेफरेन्स एलिमेन्टहरुलाई लिएर त्यो एलिमेन्टको कम्प्यारिजनमा चाहिँ हामीले मासलाई डिफाइन गर्नुपर्छ. र नेचरमा पहिला के थियो त भन्दाखेरि people used to compare all the elements with respect to hydrogen. हाइड्रोजनको मास 1 हो हैन. त्यही भएको कारणले गर्दाखेरि हाइड्रोजनको कम्प्यारिजनमा मास कति हेभी छ. लाइक when I see helium here, what is the mass of helium? यहाँ हेर त, what is the mass of helium? Tell me, what is the mass of helium? 4. Now what I do is I took out the protons, I took out the neutrons like this, and I take out the electrons. Now look at the mass of hydrogen. What is the mass of hydrogen? 1. Okay, helium ko mass kati अरे? 4. So how many times an atom is heavier compared to hydrogen? त्यति नै त्यसको के हुन्थ्यो त? Atomic mass हुन्थ्यो. बुझ्यौ मैले भनेको?
Yes, sir.
So helium को mass चाहिँ hydrogen भन्दा कति times छ? 4 times छ. That is why यसको atomic mass कति भयो त? 4. Now if you take another one, let's say this is lithium. Let me make lithium है त. Okay, so this is lithium. Okay, so now what is the atom? What is the mass of lithium here?
7 times.
7.
7. त्यो हाइड्रोजनको मास भन्दा कति बढी छ त
7 times.
7 times. Therefore, यसको mass number अथवा atomic mass कति भयो 7. So if you compare a given element with that of hydrogen को mass, जति गुना hydrogen भन्दा बढी छ, that would be the atomic mass of the given element. Do you understand what I'm saying?
Yes, sir.
Yes, sir.
Okay, now if I say the atomic mass of calcium is 40, atomic mass of calcium is 40. How many times is it heavier than hydrogen then?
40 times.
40
40
times.
times
Very good. It is how many times heavier? 40 times heavier.
3 times.
So you can define mass number like कसरी define गर्न सकिन्छ भने it is the mass of an atom, or how many times is that atom heavier compared to the mass of hydrogen. त्यसलाई के भन्छ रे? Atomic mass. Do you understand that?
Once again, sir.
How many times is the given atom heavier compared to the mass of hydrogen is called its atomic mass. Do you understand what I'm saying?
Yes, sir.
Okay, now if I say the mass of magnesium is 24, then how many times heavier is it in comparison to hydrogen?
24.
4 times.
How many times? 24 times. Very
4
good.
times.
त्यही भएर हामीले इजीमा डिफाइन गर्दाखेरि यदि हाइड्रोजनसँग कम्पेयर गरेर डिफाइन गर्ने हो भने हाइड्रोजन भन्दा जति गुना हेभी छ that is called the atomic mass. So again, remember there are two things here. If somebody asks you to define what is atomic mass or mass number when define गर्न लगायो भने what you have to say is the mass of an atom compared to the mass of one atom of hydrogen is called its atomic mass भन्न मिल्छ यदि हाइड्रोजनसँग कम्पेयर गर्ने हो भने. And if somebody asks you how would you find the mass number or atomic mass of an atom भने भने चाहिँ we can find the atomic number or mass number of an atom by adding the number of protons and number of neutrons present in a given atom भनेर चाहिँ भन्नुपर्छ. Do you understand the difference between these two questions?
Yes, sir.
Yes, sir.
Okay, one is the definition. What is mass number भन्छ. Mass number भन्यो भने चाहिँ जहिले पनि के यो mass चाहिँ कति heavy छ अथवा given element कति heavy छ भन्ने कुरा आउँछ. So for that what you have to do, you'll have to have a relative. केसँग relation गर्ने हो त, केसँग compare गर्ने हो त. You can compare it with hydrogen. Hydrogen को mass 1 भएकोले गर्दा hydrogen भन्दा कति times heavy छ, that is called its atomic mass. So you'll have to define in the same term. The mass of a given atom compared to the mass of one atom of hydrogen is called के भन्छ atomic mass or mass number. अब second type of question मा चाहिँ के सोच्छ त भन्दाखेरि what or how can you find out the mass number of a given atom? How? कसरी पत्ता लगाउने भने चाहिँ it's very simple. You'll go and add the proton and neutron and that will be the mass number. अब यसलाई अलिकति झुक्याउनलाई के सोध्न सक्छ त भन्दाखेरि which of these fundamental particle does not affect the mass of an atom भने चाहिँ कुन हुन्छ त?
Electron.
Electrons. Very good. You understand that, right? Whenever mass को comparison आउँछ भने compare yourself once आफू मात्रै अर्को चाहिँ के गर्नु पर्यो त भन्दाखेरि आफू सँगसँगै piece of paper भएको पनि सम्झिने. Piece of paper will not make a significant effect on the mass of yours. So the electrons are compared or analogous to the piece of paper that you have in your pocket. यो कुरा बुझिन्छ है?
Yes, sir.
Okay, now we don't have much time. Okay, we just have 5 minutes. So if you have any problem till now, okay, problem छ भने चाहिँ you tell me or let me do a recap. हामीले के भन्यो भने fundamental particleहरू भनेको चाहिँ तीनवटा हुँदो रहेछ basically. तिमीहरूको कन्सेप्टमा है, it will again change later on when you go. So atom बन्नलाई we have 3 different things. One is proton, the other is a neutron, and the third particle is के भन्छ electrons. When you look in this, protons and neutrons are present located in the center here, center matter. Electrons are located in a fixed path called orbit यो केसमा. Orbit मा पनि first orbit मा you have 2 electrons. त्यो भन्दा अगाडि see when I try to put it here, it doesn't stay here, it goes here. भनेपछि यो orbit मा कतिवटा मात्रै अड्छ 2 electrons मात्रै. 2n square rule भनेर तिमीले पढेको छ नि छैन र? Have you studied 2n square rule?
Yes, sir.
Electronic configuration?
Yes.
Good. So we'll come to that again. But for now, what you remember is first orbit ma ke huncha ta? Duita electron. And second orbit ma gera katiwata? 8 electron. But that is orbit concept. तिमीले 10 सम्म पढेको. 10 मा अलिअलि orbitals भनेर पढेको पढेन?
Audio.
Okay, now let's see orbital concept na ani atom कस्तो देखिन्छ हेर. Look. Do you see the difference?
Yes, sir.
Yes,
So
sir.
center ma चाहिँ के छ त? It's a nucleus. Outside the nucleus thing, this is all that blue region. यहाँ चाहिँ के हुन्छ त? Electrons are present.
Electron.
You understand that? So fixed ठाउँमा अघिको let's go to orbit model. अघिको ठाउँमा चाहिँ के थियो त? You knew electron यहाँ छ, electron यहाँ छ, electron यहाँ छ भन्ने कुरा you know that exactly. Now let's go to the cloud concept and say, where is the electron? The तीनवटा electron कहाँ छ त?
Blue color cloud.
Yes, yeah, fixed. यहाँ छ, यहाँ छ, यहाँ छ भन्ने you don't know. You only know that electron चाहिँ यो blue region मा छ भन्ने कुरा बुझ्छौ नि हैन र?
Yes,
Oh.
sir.
Yes, sir.
So this region where there is maximum probability of finding an electron, यहाँ electron find गर्ने chances चाहिँ maximum छ, but you don't know exactly where the electron is. And that region outside the nucleus भएकोलाई चाहिँ के भन्छ? It's called orbital भन्छ. Do you understand that?
Yes, sir.
Okay, now let's see what is the difference between orbital and what is the difference between orbit. अब orbit त यहाँ तिमीले fix देख्छौ कि देख्दैन त? That's a fixed circular path देखेछ कि छैन?
देखिरहेको छ.
And here is another orbit. अनि तिमीले nucleus को center लिने हो भने center बाट यो कति टाढा छ, यो कति टाढा छ, यो पनि हामीले थाहा पाउँछ कि थाहा पाउँदैन त? We can do it, right?
Yes.
So orbit भने चाहिँ के रहेछ त? It's a fixed path outside the nucleus where the electron revolves. अनि यसको distance पनि थाहा पाउँदो रहेछ हामीले, हैन? Orbit को size पनि तिमीले when you go, यो first orbit हो, यो second orbit हो, कुन चाहिँ ठुलो छ होला?
Second.
Second orbit is bigger.
Second.
So when you go away from the nucleus, orbit को size के हुँदै जान्छ? It goes on increasing. We'll come back to this concept again and again, okay? But for now, I just want you to know something about orbit and orbital अथवा cloud concept भनेको छ. यसमा चाहिँ तिम्रो के छ त भन्दाखेरि certain region मा we don't have a uniform sphere. यस्तो गोलो uniform हुन्न. Okay? अनि यसमा electron कहाँ छ भन्ने पनि थाहा हुँदैन. So there is just a probability. तिमीले भन्न के सक्छौ भने यहाँ कतै electron छ, but I don't know exactly where it is. र त्यो conceptलाई हामी के भन्छौँ? Orbital concept of an atom भन्छौँ. We'll learn later on. Anyway, I hope you enjoyed this. आज हामीले गरेको चाहिँ चार्ज कसरी गर्न सकिँदो रहेछ, आयन भनेको के हो, न्यूट्रल एटम भनेको के हो, अनि आयन्स बन्नलाई के केले असर गर्दो रहेछ त भन्ने कुराहरु पनि बुझ्यौ. आयन्स बन्नलाई के केले असर गर्छ? Protons and electrons. We don't have effect of neutrons because neutrons are neutral. Tara, when you go to mass numbers, again, what happens? The mass of electron is very, 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 very less compared to the mass of protons and neutrons. Therefore, atomic mass कसरी पत्ता लगाउने भन्यो भने चाहिँ the only two fundamental particles that affects the atomic mass are के भयो? Protons and neutrons. Electrons does not affect it. You understand that much, right? And the other thing is the mass of protons and the mass of neutrons are comparable. You can compare. उनीहरुको mass लगभग उत्रै उत्रै हुन्छ. Not exactly, but हामीले लेख्ने बेला चाहिँ mass of proton is 1 and mass of neutron पनि कति हुन्छ? 1 भनेर लेख्छौं. Okay, with this, I think I'm very happy to have myself introduced to you, and I wish we'll have a good classes later on. Thank you for being here. I think we are done with the time. Okay, enjoy your evening.
Thank you, sir.
Okay, sir.
Thank you, sir.
Yes, sir.
You too.